Welcome to the video lesson for section 9.2. In this lesson, we're going to talk about ellipses. We're going to talk about how to identify a vertical versus a horizontal ellipse and how to identify the parts of each ellipse. Let's get started. For our ellipse, we can see we have an image here, which is an oval shape, and there are several different things that we have to identify. We have a major and a minor axis. Your major axis is going to be the longer axis, so in this case, it's horizontal. Your minor axis is the shorter one, so it's going to be this vertical one. If we were to rotate our ellipse and make it more of a vertical ellipse, then those would be switched. You have a center, which is the very, very middle. You also have two focus points. We can see focus 1 and focus 2. And then to create our shape, we have a major and a minor vertex. So your major vertex are going to be the endpoints for our ellipse on the major axis, and then for your minor vertex, it's going to be the endpoints on your minor axis. Let's go ahead and look at how to identify a horizontal versus a vertical ellipse. So we have two different formulas for our standard form. We have x minus h squared over a squared plus y minus k squared over b squared. And in this instance, the denominator under your x component is larger than the denominator under your y. So we have, again, a is bigger than b, which is greater than 0. This is going to give you a horizontal ellipse like we saw with our last example. If instead we see that our larger denominator is under your y component, then we're going to have a vertical ellipse. So it's going to be standing up instead of side to side. All right, let's go ahead and compare how you find the parts for your different ellipses. On the left side, you see that we have a horizontal ellipse because our a value is under our x component, whereas on the right side, we have a horizontal ellipse because your a value is under your y component. Regardless of which type of ellipse you have, your center is always hk, where h is always found from your x component and k is found from your y component. For your vertices, we have major and minor vertices. For your horizontal, your major vertice is going to be h plus or minus a, comma k, and your minor vertice is going to be h, comma k plus or minus b. And these are going to be the endpoints of your ellipse and help you form your ovalness. For your minor axis is always going to be x is equal to k, and your major axis is always going to be y is equal to h. To find your foci, we have a formula which is the same for both. We're going to find c, and c is always going to be the distance of the square root of a squared minus b squared. To find the foci for the horizontal ellipse, again, it's going to be h plus or minus c, comma k. If we compare this all to your vertical ellipse, we can see again, center is still hk. For your major axis, it's now going to be h, comma k plus or minus a, so it's going to be going up and down. Whereas your minor axis is going to go side to side. It'll be h plus or minus b, comma k to find your minor vertices. The major axis is going to be x is equal to k. The minor axis is going to be y is equal to h. And then once you have found c, for your foci, it'll be h, comma k plus or minus c. So once we've identified if you have a horizontal or vertical ellipse, we can go ahead and find all these parts. In order to measure the ovalness of your ellipse, we have something called eccentricity, and the e value is always going to be equal to c over a. For our example here, we're going to go ahead and find the parts for our ellipse. The first thing we want to identify is, do we have a horizontal or a vertical ellipse? Looking at our denominators, I see my larger denominator is under my x value, so that tells me I'm going to have a horizontal ellipse. Before I can find all my parts, I want to identify a, b, and c. Since my larger denominator is a squared, that means the square root of 25 is going to be a, so I can say that a has to be 5. And then b has to be 2 because it is a square root of my lower denominator. To find my c value, again, I have the formula of a squared minus b squared. So if I plug in my two denominators, I get the square root of 21 is going to be c. And then I can also pull out my h and my k values. Again, h is always pulled from your x component, and k is always pulled from your y component. So I can see that h and k are going to be 2 and negative 8. Now that I have the information, I can go ahead and plug everything into my formulas to find all my parts. To find my major vertice, again, it's going to be h plus or minus a. So you can see that here, 2 plus or minus 5, comma negative 1. And then for my minor vertices, it's going to be h, comma k plus or minus b, and I can see that over here. Those points are going to simplify to be 7, negative 8, negative 3, 8 for your major vertices, and then 2, negative 10, and 2, negative 6 for your minor vertices. In order to find my two focus points, I have h plus or minus c, comma k, so I went ahead and plugged those in. And then the last thing I would need to find would be my eccentricity, which would be c over a. giving me radical 21 over 5. The other two things that I could identify would be my major axis and my minor axis. So my major axis would simply be x is equal to y equal to -8, and then your minor axis would be x is equal to 2. For our next example, our first step here would be to write it in standard form. So I see that I have x squared plus 9y squared is equal to 36. And I would do this by dividing both sides by 36. So divide by 36 on the right side and also on the left side. And I end up getting x squared over 36 plus y squared over 4 is equal to 1. Again, I can see that the 36, my larger denominator, is under my x value. So I know this is going to be a horizontal ellipse. I can go ahead and find my a, my b, my c, and also my h and k values now. So a is going to be the square root of 36, which is just 6. B will be the square root of 4, which is just 2. Plugging in my 36 and my 4 to find my c value, I see that I get the square root of 35 as my c value. And since these are just x squared and y squared, my center has to be 0, 0. Since my a value is under my x, it's going to help me find my major vertices. So I have 0 plus or minus a, comma 0, which ends up simplifying to be the points -6, 0, and then +6, 0. To go ahead and find my minor vertices, we have 0, comma 0 plus or minus b, which is plus or minus 2. Give me the two minor vertices of 0, -2, and 0, +2. Because I have a horizontal ellipse, I know that I'm going to be adding c to my h value to find my focus points. So I have 0 plus or minus radical 31, comma 0. And then finally, to find my c value, it would just be c over a, which is going to be radical 31 over 6. But when I define again my major axis, it would be y is equal to 0. And if I'm my minor axis, it would be x is equal to 0. All right, in this example, we definitely have a little more work cut out for us. We want to write it in standard form before we can find the parts. In order to put it into standard form, I'm going to have to group things together and then do some completing as a square. So I'm going to get my x values together, also get my y values together, and we can move that 2 to the other side. So I have 6x squared plus 18x plus 2y squared minus 10y is equal to -2. Now that I've grouped together my x and my y values, I can go ahead and begin to complete the square. So I can factor out my coefficient here to get a 1 next to my x. I can also factor out my coefficient here to get a 1 next to my y. And now that I've done that, I can start to begin to complete the square. We're going to take half of our middle term and square for each of our components, your x and your y values. So when I do that, I end up getting a 9 over 4 and then a 25 over 4 here. But remember, we have to take this value and multiply it by what we factored out. So this is really a 9 over 4 times 6, which is why you see on the right side I have a 54 over 4. And this is really a 25 over 4 times 2. Again, that's why I have this 50 over 4. And I'm adding these to the right side to go ahead and balance my equation. What I can do now is I can go ahead and I can factor both of my expressions because they are perfect squares, and I can simplify my values on the right side here. And you see that now we have 6 times x plus 3 squared plus 2 times y plus 5 halves squared is equal to 24. My last step is I need my equation to equal 1, so I'm going to divide both sides by 24. And when I finish doing that, I have x plus 3 halves squared over 4 plus y plus 5 halves squares over 12 is equal to 1. Now that I have it in standard form, I can identify if I have a vertical or a horizontal ellipse. Looking at my denominators, I can see my bigger denominator is under y, so this time I'm going to have a vertical ellipse. For example here, we have some parts. We're going to go backwards and try and find the equation. So we're given that our center is at 0, 0. We have vertices at plus or minus 3, 0, and foci at plus or minus 2, 0. Our vertices are going to help us identify what our a value is. These are representing our major vertex, and it's the distance our vertices are away from the center that tells us what a is. So since I'm moving in either direction 3 from 0, I know that my a value is going to have to be 3. Your foci is going to help you identify what c is, and it's going to be the distance the foci are away from the center. Again, I'm moving 2 in either direction from my center, so I know that my c value is going to be 2. Knowing my a and my c value, and also knowing h and k, I can identify b, and I can also identify what my equation looks like. So again, knowing that a is 3 and c is 2, I can plug them into my equation. C equals the square root of a squared minus b squared, and I can solve for b, which gets me that b is equal to the square root of 5. Now I can also identify h and k as 0 and 0, and I can plug it all in. Since my vertex is moving in the x direction and my foci is also moving in the x direction, I know my a value is going to have to go under x, and that means my b value is going to go under my y in my equation. So we can see that I have x squared over a squared plus y squared over b squared. When I go ahead and I simplify this expression or this equation, I end up getting my final equation of x squared over 9 plus y squared over 5 is equal to 1. In our example here, we're given the foci at 5, 3 and negative 3, 3, and then our major axis is at 16. Our foci is going to help us identify C, and our major axis is going to help us identify A. Since A is the distance from the end point or your major vertices back to your center, it's going to be half of the length of your major axis. So my A value is going to have to be half of 16, which is 8. For my foci, they are the same distance away from the center, and that allows me to identify what my C value is. So since I can see the distance from 5 to negative 3 is going to be 8, half of that would give me my C value, which would be 4. So I know that my A value is going to be 8, again, because 8 is half of my major axis. And my C value is 4 because it's half the distance away from your foci. Using my A value of 8 and my C value of 4, I can now find B by plugging them into this equation. And we end up getting that B is the square root of 48. And then H and K is going to be my center. And I find that by finding the center or the midpoint of my two foci. And I'm getting that the midpoint of 5, 3 and negative 3, 3 is 1, 3. Okay, so now that I have my H, my K, my A, and my B value, I can go ahead and write things. Before I do that though, I want to identify where does A go. Knowing that my major axis, knowing that my foci are moving horizontally, that tells me that I'm going to have a horizontal ellipse, which means that my A value is going to go under my X variable. So I have X minus 1 squared over 8 squared plus Y minus 3 squared over radical 48 squared equals 1. Simplifying my radical 48 squared and my 8 squared, I get my final equation. Again, I want to note that I knew that 8 had to be under my X value because my foci are changing in the horizontal direction, which means that I have a horizontal ellipse. If my Y values were changing instead, that would tell me that I would have a vertical ellipse and I would have put the A value under my Y value. All right, that does it for our notes for this section. Go ahead and get started on the homework, and good luck.